Now that we have all three boilers in line working, we're going to wait for the controller to stop the operation of these three boilers and leave just one or two depending on the temperature. So we're just going to wait for that controller to turn it off, and it may take a minute or two. So in the meantime, I will show you the gas drain. Basically here we have the power head that will allow the boiler to go into a high or low fire depending on what the internal controller is calling for. We can see that black box right there, that's the transformer that will provide 10,000 volts to the igniter and ignite the pilot that will ignite the main flame. So over here we can see the igniter and the wire connected to the electrode, and it goes back to that transformer in the back. We can see the piping in the solenoid valve and also a regulator for the pilot. You can see also the linkages for the dampers that will allow the boiler to go into a low or high fire depending on the call. And we can see that our boiler is still calling, and it will be de-energized any minute now. In the meantime, we'll look at the high and low pressure switches and also our gas regulator. We have, with boilers, we have redundancy and safeties, and depending on the design, we can have two or more of these switches in series to ensure that the boiler is always safe to operate. With the control panel, you can see we have our motor starter with the overloads for that blower motor. We can have our transformer and all the related wiring, and also we have relays that will stage or de-stage that the operation of the boiler. Let's remove the box so we can see. It's kind of difficult with one hand. So we can see that our display module, this controller has three modules. The top module is the display module. We have the programmer and the flame amplifier module. Let's see if the light helps. We can see all three components of the module that basically it's the brains of the operation, and it will stage, energize, de-energize the boiler, or make it go into high or low fire depending on the call. And also it will give us the flame signal that is required for the boiler to operate, because we want to ensure that we have full combustion, either low or high fire, at all times when the boiler is operating. So most boilers also, or actually all the boilers, have a series of controllers, and in this case we have our operator. Right now just the boiler next to me was de-energizes, and it's in the process of stopping. It just did. So while we wait for this one to be de-energized, I'm going to show you the operator and the high limit. Right now, that operator and the high limit, the operator, we have this digital control that takes the place of the operator. So right now we're not using that, but the high limit is actually, it's another safety device that will allow the boiler to stop in case the temperature gets too high. We also have our low water cutoff device. When the water gets too low, it will stop the control circuit from operating and will bring the boiler to a stop. We also have our control for our recirculator pump to make sure that we have enough flow of water going through the boiler, so to ensure that we don't have an unsafe condition. Right now we can see how the boiler, the temperature keeps going up 183 degrees. Our outdoor temperature is 64 degrees. And as the temperature continues to increase, we will see how the second boiler will be the stage. I can show you the pump, the circulator pump that allows the boiler to have constant flow of water, and now we see an unsafe condition right there because it looks like someone is working on it, and then he left a drop light and those wires exposed. That has to be fixed, because and we'll do that as soon as I'm done with this video, because we cannot have exposed wires like that. Anyway, we also have relief valves. Redundancy, we have two of them in case the temperature goes too high. The relief valves will open and allow the hot water or the excessive pressure to be discharged into the drain, central discharge, instead of creating unsafe pressure conditions for the boiler. At 185 degrees, we can still see that our boiler is still working, and then it may take a few more minutes, and in the meantime, right now we get the call, and then we can see the post-purge cycle complete, and the motor, the blower, operated for about 15 seconds to ensure that all natural gas was used and all the combustion products and unburned natural gas was removed from the firebox. So, and that completes the sequence of operations for the boiler.